Hello everybody, today we're talking about segment and angle bisectors. Bisector is kind of similar to a bicycle. It involves two of something. So the first word we're going to need is the midpoint. The midpoint is just the point that divides a line segment into two congruent segments. And what you're going to see is this little pink mark that I made, a little vertical dash that indicates that AC is the exact same length as CB. So that little dash is very important. It tells us that those two pieces are congruent to each other. Now, when we do something like this, we call it bisecting. Bisecting is like an action word. It's to divide something into two congruent parts. Now, similar to the distance formula, we're going to learn a fancy way to do this, but it really just involves averaging the coordinates. So if I know the point A and point B, which are the endpoints of the line segment, I can find that middle point by taking the x values, adding them together, and dividing them by 2. And this is finding the average x value between the two of them. And we can do the same thing for y. It doesn't matter if your x and y values are positive or negative, it works out just the same. So the midpoint formula is one that you need to memorize. So you're going to take x1 and x2, add them together, and then divide by 2, y1 and y2, and then divide by 2. Here's an example. We've got a at -2, 3, and b at +5, -2. We're going to take the x values, which are always the first number in the pair. They're in alphabetical order is one way to remember. So -2 and 5 are my x values. We add them together, and because my 5, the positive number, is bigger than the negative number, I end up with a 3 on the top of that fraction. We do the same thing with the y values. I'm adding 3 and -2, and when I'm adding a negative, it's kind of the same thing as just subtracting. So 3 minus 2 would give me 1. This is one that would have been really hard to see on a graph. It's hard to find 3/2, 1/2 as the exact midpoint. So this is an example of why having a formula is very useful. We can use it for midpoints that are not clearly a nice, neat point on the coordinate plane, or we can use really big numbers or things that we don't have graphed. I didn't even show you a graph this time, and you were still able to find the midpoint. Now, in class, we're going to try some harder questions for this as well. If I give you the midpoint and I give you one endpoint, you can use that information to work backwards and find the other endpoint. So here I gave you R, which is at -1, 7, and that's an endpoint. And I told you the midpoint is at 2, 4. So we know basically the answer, 2, 4, and we know half of the information that was inside of the formula. So you can see where I filled it in. -1 plus some x value divided by 2 is going to be equal to our midpoint x value, and 7 plus some y value divided by 2 is equal to our midpoint's y value. What we do is we take each part of this, the x and the y, and we separate it into two equations. So I'm going to take the x part, the -1 plus x over 2, and I'm going to set it equal to the x value of the midpoint, which is 2. You can see how I solve this. To undo the division by 2, we're multiplying by 2, and then last we add 1 to get x is equal to 5. And the process for the y value is going to be almost exactly the same, except our second step, we're going to subtract 7 because it's positive. In this way, we were able to find that the other endpoint, P, is at 5, -1. Now, angles can also be bisected. It just looks a little different. So an angle bisected is going to be bisected by a ray instead of a point. The ray is going to divide the angle into two congruent adjacent angles. You'll see a little pink mark that I've made. That is the congruence mark for angles. So instead of having a dash like we had for a line segment, we use a curve. And you'll see I also offset it a little bit so you can see that I'm saying the top angle ACD is congruent to the bottom angle DCB. Now in class, we're going to use this in a very algebraic way. So here's an example. I've got angle PRS, which is bisected by the ray RQ. The angle PRQ is x plus 40 degrees. Now this is super weird, right? I'm not asking you about like, if this angle is 45, what's the other angle? Because that's just too simple. If they're congruent, you would just tell me it's 45 degrees. So instead, we're going to be doing some algebra. But because we know that PRQ is congruent to QRS, all we have to do is take whatever PRQ is equal to, in this case, x plus 40, and we're going to set it equal to QRS, which is 3x minus 20. And then we go back to algebra and we solve it in the same way we would. We'd get the variables to one side, we'd get the constants or the numbers to one side, and then finally we get x by itself. In this case, they didn't ask us for the degrees of the angle. They only asked us to solve for x. But if you wanted to check, you could always plug x back in to find the number of degrees. So for instance, for PRQ, I know that the degrees are equal to x plus 40. So that's basically 30 plus 40 for a total of 70 degrees. Now theoretically, QRS should be exactly the same amount. So we can check. This one's 3x minus 20, and that's 3 times x, so 3 times 30 is 90. 90 take away 20 leaves me with 70 degrees. Excellent, we got congruent angles. And that's how you would find the angle measurement if you were asked to plug it back in. Last for today's lesson, we're going to learn some constructions. A construction is a geometric drawing using a limited set of tools, usually a compass and a straightedge. A compass is basically just a two-pronged device. One end has a pointy end, and the other end has something that you can draw with. Our straightedge is a ruler that has no markings, and the purpose of using these tools is to show you how geometry has been developed over centuries. These tools are so primitive that they were able to use them in ancient Greece or ancient societies and to discover the same geometric principles that we're studying today. You have 2 construction videos to watch. One is the perpendicular bisector video, and the other is the angle bisector video. In class, we're going to be creating both of these constructions, so you may want to watch it multiple times until you feel comfortable that you could do it yourself. All right, that's it.